Welcome in, everybody. We're going to start a brand new topic called classes. This is a different style of programming. It's called object-oriented programming. We've actually seen this type of programming before, but today we're finally going to formalize it. And you'll be able to create your own custom types. Alright, so let me go through this. There's a couple of topics here. These are incomplete. I'm going to add a couple more here. But yeah, just a couple. Well, we're just going to cover this first part today. Intro to object-oriented programming. Okay, so just as a quick overview, object-oriented programming is kind of a style that lets you define your own type of variable. It allows you to create like a custom variable with custom methods attached to it. All right, so yeah, sometimes you want to invent like your own library. Maybe you want to invent like a new type of variable, so you can give it to other people to work with. Like say you're working at a company, and the company needs tools to do things easier. In that case, you might find yourself writing a new library. You might find yourself inventing a new variable, so your coworkers could use it. All right, and this lets us organize methods into a nicer interface too. This is called encapsulation. So here, let me just comment this out real quick. Encapsulation. This is a term that we're going to learn in just a bit. Encapsulate kind of means to hide things away, and sometimes you might want to hide away details. This way, other people can use your things a little easier. It depends though. It depends on what you're trying to hide. Okay. Anyways. We'll repeat this in just a bit. I think we should point out some examples just to make it a little more concrete. So we have seen object-oriented programming before. Back all the way in week 1, we saw a class called string. So we've seen this right here. This is like declaring a variable of type string. However, it's like a fancy variable. You can consider this a class. A class is kind of like a cookie cutter. A cookie cutter allows you to make cookies. So the cookie here is called an object here. But basically, the general version is string, and then the more specific one is object. All right, so this is kind of what I mean by cookie and cookie cutter. A cookie cutter is the class, and then the cookie is the object itself. All right, these are two terms that I'm going to be using a lot today. I'll define them in a couple more slides, so just give me a second. Okay, so we've seen methods too. Like strings, they have methods like dot length, right? Like you could do a bunch of stuff. Let me pull up my J shell. Or actually, you can even look at this documentation over here. So this link on the bottom, I got it by looking up strings in Java. So you can look up string in Java, and then it should be the first link over here. So this is a primary documentation. A string is a class, meaning it's kind of fancy, and it's got a bunch of methods here. All right, in particular, there's something called a constructor. We're gonna define this in just a bit. Constructors are methods that help you create an object. All right, so we'll talk about that in just a bit. There's also plain methods too, like this length over here. We've used this before, this length func method, which you can use pretty much like this over here. You can say, well, first let me construct a string. So you've seen us construct a string before. It goes like hello. This is one way of constructing. You'll see another style later. Another style you'll see later is gonna be using like a constructor instead. So another way you could construct a string is by saying this is equal to a new string, and then hello here. So both of these are pretty much the same. There's some slight differences between them, but today we're gonna see this style over here. So yeah, they do the same thing. So if I declared a string like this and allocated it some memory, you can use a bunch of methods like length over here. You can use like a text dot length. All right, and very important, this dot, it's gonna be pretty important today. This dot means that there is a method attached to this left side of here. All right, meaning that the string class has a member method called length, and this gives us 5. You can do a bunch of other things too, like I guess for some reason, if you wanted to lowercase some stuff or uppercase, if you wanted to uppercase something, there is a method for it. So you could go like text dot to uppercase, and then this returns another string that's all caps. So these are methods that we'll be talking about today. We're actually going to be creating our own custom methods like this. All right. So yeah, this is just some terminology. I'll formalize them more specifically in just a bit. But yeah, this is a class that we've seen. Object-oriented programming. In object-oriented programming, you typically see a lot of periods, like something, like some object, period, something. All right. For example, random. This is another class that we've seen. You've used this in your previous assignments, your loon generator, I believe, and blackjack. Blackjack also uses this class. So here, this line is declaring a object. Right? The object is an instance of this class. So I'm creating an object, and then I'm using a constructor. If you're curious what this stuff is, I'll pull it up. It's on the docs over here. I'm using this constructor over here. This is a method that creates a new random generator. So that's what the constructor here is. All right, we're gonna be making our own constructors today. It's gonna be some pretty cool stuff. And then yeah, you can do a bunch of things with this RNG, with this random object. You can do like dot next int. Let me do an example over here. The J shell. So random RNG. This object name doesn't matter. You can name it whatever you want. And then you go random. So this is calling the constructor, which creates an instance. And then you go enter. And don't worry about this. This is some other data. But you can do things like well, I could look at the documentation to see. So you can look up random class in Java, and there's a bunch of methods you can do. Let me see. We've used this one before. Next int. This is rng.nextInt. It takes no parameters, but it does return an integer. And yeah, you can pretty much spam this over and over again and to give random numbers. There's also this one over here that we used. This one takes a parameter and upper bound. So you can give it an upper bound as well, like 10 here, which will give you from 1 to 10. All right. Cool. So yeah, once again, objects and member methods. These are methods that belong to the class. All right. Finally, we've seen an array list too. This is a fancy class. It's we got the class, which is an array list of strings, and then the object's name is hotbar. You can name it whatever. I named it hotbar to kind of represent like a Minecraft thing. Like you might remember a while ago. We did an example that kind of represented this hotbar. In some games, they have like an inventory, and you can access it through some sort of data structure. All right, so that's why I call it a hotbar. There's a constructor here. I could pull up the documentation again. Let me look it up. Array list in Java. Click on the primary docs over here. So we use a constructor here. That's this over here. This is a constructor. It constructs an empty list. Oh, initial capacity of 10. Nice. I didn't even know that. And then there's a bunch of other methods I can do to here too, like length. This returns a size. You can also do a bunch of other things. You've seen this method here, add, which is a way of populating the array list. All right, like if we went ahead and used this, let me go ahead and use it. I'm gonna construct it first. So let me construct an array list of strings. And I'll call it hotbar. And I'm gonna set it equal to the I'm gonna set it equal to this constructor over here. So new array list of strings. And then yeah, so here's my empty list. We can use methods here. This is a member method. Add. So you can do like hotbar.add and see you add like a pickaxe or something. Just some random string. Now if we look at our hotbar, we see there's one item in here, and we can add some more stuff like maybe like a sword. And then we take a look at the hotbar. Hotbar is now 2 strings in here, which you can access things. Here, let me add one more. Let me add like an axe or something. Doesn't matter. So we got the hotbar here. It's 3 items, and you can access individual elements with this method called get, which takes a number. So you can do like hotbar.get 0. This is going to return a string. Pickaxe, and you can do with the rest of here to the all the way to the last one. All right, so yeah, these are just member methods we're playing around with. This is kind of what object-oriented programming looks like. It looks like an object and then dot some method here. This style of programming makes things a little easier to read. All right. Okay, let's go ahead and make our first custom class. All right, it's something that's not going to exist in the standard Java. We're going to invent our own class. All right, so real quick, I've been talking about classes and objects. I like to picture it as a cookie cutter versus a cookie, where a class is like a cookie cutter, so like a generalization, and you can make a bunch of cookies from that class. All right, so I call them objects here. One class can make tons of cookies. So this is the object right here. All right, I'm gonna formalize this a bit more after this example, but let's go ahead and do one example. We're actually gonna invent our own type of class, and it's really just going to be like a fancy integer. That's really what it's gonna be. But you'll take some stuff out of from this example. So imagine a tally counter. This is like a device that keeps track of numbers. There's a couple buttons here. There's like a plus, a minus, and then there's a reset button too. The reset pretty much resets it to 0. All right. So you can represent this tally counter as a class, like a cookie cutter. You can say every tally counter has some private attributes. Private attributes are like variables that describe the tally counter. All right, so what's a variable that can describe a tally counter? Well, maybe some sort of number. All right, so maybe like an integer that represents its value. All right, but we can also add in some member methods. So this is called the public interface. The public interface are the buttons. It's what is the user allowed to do. Right? The user is allowed to press the reset button. They're allowed to look at the value, and they're also allowed to increment and decrement. Right? These are kind of like buttons. Like we got a reset button here. This is public. Anybody can press it. We have a get value. This is not really a button, but it's public. It's a public interface, meaning the user can see the value here. All right, and then there's a couple buttons here, the plus and minus. These buttons control the inner value, the inner private value. Okay, in a bit I'll talk about what the differences is between private and public. Basically, private means other people or other things can't touch it, and public means anybody can touch it. All right, this will make sense in just a second. But we're actually going to go ahead and define our own type of class right here. So here, let me pull up my VS Code, and I'm going to create a brand new directory for this. So let me create a brand new directory because I'm planning on having 2 files for this. I'm planning on having one file that represents the main, and then another file that represents a representation of this cookie cutter. All right, so let me make a whole folder for this. I'll call it counter project. Okay, so here's a folder, and let me go ahead and make 2 files in here. It's gonna make sense why I did this. Let me make a main and also something called counter.java. Okay, cool. So I have 2 files here. A main. Let me put the main over here real quick. And I also have a counter.java, which is currently empty. Let me cd into here. Cd into counter project. I should see those 2 files now. Okay, cool. I do see them. Nice. All right. So what does it mean to create your own type of variable? Well, we're designing like a fancy integer. That's what we're pretty much doing. Imagine if there was a class called counter. This means we would be able to declare like a counter variable. Right, so this is like a type, and you can call it whatever you want. I'm gonna call it a tally here, uppercase tally. All right, so check this out right here. Check this out. I'm declaring an object from the class counter. Right, the object is named tally, and the class name is counter. All right, let me see if this compiles real quick. It shouldn't compile because this doesn't exist. So it doesn't exist yet. So let me just Java the main. This is gonna compile it, and we get an error message. It's pretty much saying I don't know what counter is. So the bare minimal syntax required to make this exist or invent your own counter is with this over here. So I'm gonna go into the counter.java. Let me put this side by side. Okay, zoom out a tiny bit. So this is counter.java. In object-oriented programming, there's typically the class name that is the same name as the file here. So the bare minimal syntax to make this counter exist is by putting public class and then the name of whatever you're trying to invent. Right, I'm trying to invent something called a counter here. All right, and then we need some semicolon. I mean these curly braces. These curly braces represent the cookie cutter. So everything inside of here represents how the counter looks like. Okay, so let me just comment out this real quick. This is declaring a class. All right, it's not a method. All right, it looks like a method because there's some curly braces here, but it's not. This is saying it's pretty much like this right here. You could read it like this in one line. It's saying make a class that's public and call it counter. All right, that's pretty much what it is. Now let's see if it compiles. So I'm gonna go ahead and Java it real quick. Java, and then okay, cool. It compiles. It doesn't do anything yet because there's no like output or input. But one of the styles of programming, of object-oriented programming, is the periods. So you'll typically see something like let's see. You'll typically see this right here. This is a bad programming practice, by the way. You'll see something like a period, like a object and then period something. All right, imagine if you were able to like say value here. All right, so I'm attempting to access a variable called value that belongs to this object. However, if I were to do that, like here, let me print this out. Let me just print a line here. If I were to try to access this, it's probably going to give me an error message here. Let's see. It's going to say tally does not exist, or it says cannot find symbol. It's pointing at the period value. So it's pretty much saying the value doesn't exist. So one way you could fix this is by making it exist in the cookie cutter. All right, saying that every counter has a value. All right, so this is a bad programming practice right here, but you could declare like a an integer called value, right? And also making it public. So, well, here, let me not do public yet. Let me try to compile this. So let me run it. And okay, so we get a different error message this time. The earlier error message it said it couldn't find value. Now that's gone. Now it's saying tally might not have been initialized. Right, which so it's saying that we never initialized this tally, meaning we're missing like an equals to something. All right, so this is like this is where a constructor comes into play. When we're calling a constructor, it's attempting to initialize a cookie. So this is like saying create a cookie. Let me go ahead and do that over here. So you can say it's equal to a new counter. All right, so this is the constructor right here. Okay, it actually doesn't exist here yet, so we're actually calling it a default constructor. All right, this will make sense in just a second. Give me a few more minutes, folks. But let me go ahead and test this now. So let me go ahead and run it, java main.java, and then check it out. So it did run. It did run. So it did compile and run, and it's printing 0. All right, so 0 comes from here. So we can tell that by making a cookie and calling it tally, we ended up constructing a counter, right? And its value is 0 because that's a default value for integers that are not defined. All right, this I believe is public by default, meaning you can change it. Anybody can change it. Like here, imagine you're a main. Right, the main is allowed to change this. Like the main could do tally.value is equal to 100. Right, and then go ahead and let's test it. Let me run it, and then now it's printing 100 here. Right, you could change it again. Tally.value is equal to 200. Right, and then go ahead and run it again. We get 200. All right, so what's happening here? This is kind of a bad programming practice because we're trying to represent a counter with a public interface. However, what we're doing here is modifying something that's really supposed to be private, right? Like, isn't it inappropriate to is it possible to do this? Like if I were to give you a tally counter right here, right? Like let's say I give you a fresh tally counter, would you be able to change the number to 100 in like one command, right? Like right here, I'm changing the value in one command. That shouldn't be possible. It should be that the only way to get to 100 is by pressing plus like 100 times. All right, so this does work, but it's possibly bad programming practice because we're not representing the public interface correctly. All right, so this kind of means we need to make this private over here. So by making something private, you would prefix it with private. This keyword makes it so people can't misuse your class. Meaning that if you were to publish this class here and give it to your coworker would not be able to modify its value directly. Right, like let me compile it again. See, so I went ahead and compile it, and there is a error message. It's pointing in the main. It's saying, hey, we can't do this. It's saying value is private. So by making things private, it prevents misuse. Private variables prevent misuse. Okay, which we just did right here. We're preventing people or other methods from kind of cheating, right? Cheating, like changing the thing in one command, changing the value. All right, so this is no longer possible. Yeah, so let me remove this. And this is also no longer possible either. Let me see, let me try running it. All right, see, I try running it, and now this is an error message. It's saying this is private. So yeah, this is, it looks like we broke it, but we're actually preventing misuse of it. All right, there's a safer way on doing this. So let me talk about that right now. There's a safer way to use it, and it's more of the style of object-oriented programming. Like you could imagine a well, you can imagine like a get value method. So this is a public interface, meaning we're giving the user ability to see the value. All right, right now the user here doesn't have the ability to see it. So it might be necessary to create some method that's public. Right? Create a public method so anybody can access it. And in this case, maybe I want to create like a method that returns an integer, that returns what the counter's value is. All right, so check this out. This is gonna be pretty cool. So you can do like you can make a function, a method that returns an integer. All right, so I'm trying to represent this right here, this get value. All right, I'll do the reset later, but maybe do this get value. So since it returns an integer, I'm gonna say it's an integer, and that also it's called get value. All right, so this right here, oh, I need to make this public as well. All right, and let me comment this real quick. So by making it public, it's saying that other people or other parts of the code has access to this method. All right, so public access, public member method. All right, that's what this is over here. This method is supposed to return an integer. In particular, it's supposed to return whatever the counter has currently. So one way you could do that is by saying return this.value. All right, I'll explain what this means. In short, this is a keyword which is pointing at itself. Right? Itself here would just be tally. So this represents the current instance. Right, the current object's instance. Okay, so let me go ahead and run this real quick. So Java main, and then okay, so I meant to change this over here. So this is a private. We ended up creating a public method that gives read access to this value, and we can invoke that by using this by saying tally.getValue. This is the style of object-oriented programming. You see a lot of dots. All right, so I'm accessing a public member method, and now if I go ahead and test it, it now prints 0. Cool stuff, right? Cool stuff. Okay, cool. And I'm not sure if people see the bigger picture yet, but this is a cookie cutter, meaning you can create multiple cookies from here. Like you could say, you could create another one. You could say, hey, make a tally 2, right? And then say, okay, this is equal to a new counter. So this is another default constructor. Right? So I have 2 cookies from the same cookie cutter, right? And we can go ahead and access it. So let me go ahead and access its value. All right, let me go ahead and access it and run it, and now we see 2 zeros. Right? They do look the same, but they're they're 2 different zeros. Right? One belongs to the first tally and one belongs to the second. All right. So all we did so far was represent a counter that just displays 0. We should probably implement a couple more functions, methods, like increment, the plus button, and the minus button. This will allow you to kind of change its value here. So I'm trying to do stuff like let the user press buttons, right? The user is on the left here. So imagine if they could do something like tally.increment. Right, people see what I'm trying to do here. This is saying grab the first tally and press the plus button on it. Right, that's what I'm trying to do. Unfortunately, it doesn't compile here. It's Java compiler says increment doesn't exist. So let's go ahead and make it exist as a public. Right, we need it to be public, otherwise the main would have no access to it. Okay, so let me go make a public method. And well, with the method, we need to describe its type. All right, what is the type for this over here? All right, well, what are we expecting this button to return? Well, based off this main, probably nothing. You see how we're not like, you see how we're not storing it into anything, right? Like if I said something is equal to tally.increment, this means we're expecting this method to return a value. Right? But the style that I'm doing it in, we're not really expecting it to return a value. We're just expecting it to do something. So you can assume this is a void function, void method. All right, so void method, and it's called increment. Okay, cool. So here's a increment method, and it should modify the counter's value, right, by 1. So you could increment it. You could say this value is equal to this value plus 1. Right, this is incrementing. And yeah, once again, this is an object that's representing the current instance. So in this case, it's tally right here. Oh, I meant to make this a 2 earlier. Tally 2, my bad. Okay, so let me go ahead and run this real quick. Save both of them, and check this out. Check it out. So let me go ahead and run it. Wait, before I run it, what do folks think is gonna happen? Right, like what is the first value gonna be? What is the second value? Oh, let's see. So we see that the first value is 1, and the next value is 0. Hopefully that makes sense, because we only incremented on one of the tallies. Alright, so if I were to do like tally.increment again, right, this is saying go here, increment the current one, and now we get 2 and 0. Right, the second tally is staying the same. Alright, so you can do some other stuff like tally2.increment, and what do you think the output is going to be now? This is like a possible exam question. I'm seeing if you can read code. All right, if you're reading this, what's the output going to be here? 2 and 1, because this one got incremented once. All right, people cool with this so far? Check the chat. Okay, people good so far. Sweet. I would probably spend a bit of time, if you want to pause the video and try to implement the rest of this public interface, that would be a good use. You could probably pause it for like 10 minutes, 15 minutes, and see if you can get the rest done. But yeah, we did the increment method. Now we need to do the decrement and the reset as well. We don't have this button implemented yet. So I'm gonna go ahead and do this. If you're on the video, I would recommend pausing it and seeing how far you can get. Let me do the decrement method here. So imagine if we had the ability to do something like tally.decrement. This means to subtract 1. All right, but if I were to compile this, hopefully people see what's going to happen. Decrement doesn't exist, so we need to invent it. We need to make it exist. All right, as a public method. So let me make a public method, and once again, I'm making it void because we're not expecting it to return any value. Because there's no equal signs here, right? We're not storing it. So let me make a method. I'll call it decrement. And then this is the opposite of here. So this dot value is equal to this. All right. So what do you think the output's going to be now? Let's see. So we have 2 tally increments, and then it decreases. In the second tally increments, Right, so we should get 1 and 1. Okay. So yeah, there we go. We get 1 and 1. All right, and here, let me just do it one more time. Let me go tally 2 dot decrement. All right, so just modifying it. What do you think it's gonna be now? Well, this should be 1 plus 1 minus 1, so this is 1, and this should be 0 because these are opposites of each other. Okay, so yeah, we get 1 and 0. All right, people cool with this so far? All right, cool. We should probably set up some other ones too, like this reset method. This is like a button that changes the private to 0. Right, sets it all back to 0. So if I did something like here, if I said tally.reset and then tally, yeah, just tally.reset over here. Right, this is saying grab the first tally and press the reset button. So let's go ahead and invent that. It needs to be a public function, public method, and then call it reset. All right, and yeah, what do we do here? We should probably set it to 0. So we could say this value is now equal to 0. All right, so what do you think is gonna print now? Well, we only reset one of them. What's these are possible exam questions. What's the output? Let me run it. So we get 0 and 0 because they both got reset. All right, you could also reset number 2. We're gonna get the same exact behavior. 0 0. Yeah. People cool with this so far? Okay, sweet. I do want to point out something though, like okay, so first of all we did so far was represent a fancy integer. We spent a lot of work making an integer kind of look too complicated. Honestly, this is a really small example, and we're gonna move on to bigger examples later, so it'll make a little more sense. But here we're just doing a fancy integer. All right, that's really what it is. But this integer should have some protection. We created these buttons here to allow the user to use the tally safely. All right, remember in the beginning, in the very beginning, value was public, meaning it gave them access to change things. Like this would be considered a kind of like a hack right here, which doesn't work. If I said tally.value is equal to like 1 million, all right, this is like a person who's trying to misuse your class. All right, this should be impossible. First of all, it should be impossible because there's only 4 digits here. It's impossible. Not because of that, but it's because this is private. All right, so hopefully people kind of see why things are private. Because if this was public, right, if this was public, now this inner value is unprotected. Meaning, if I were to run it, we get 1 million or something. All right, this does work, but it's not a proper representation. All right, so let me change this back to private. Hope that makes sense why you make some things private. Okay. But there's also some protection we should do. Earlier I was talking about there's only 4 digits in here, meaning it should be impossible to go to a 10000, like 10,000. It's impossible to represent 10,000 on this tally counter. But with our current implementation, it's possible. See, check it out. Let me just remove these over here. Let me simulate me pressing this button like 10,000 times. All right, so I'm just gonna do it in a for loop. A for loop tally.increment, where I'm planning on pressing the increment button 1 million times. So this is one way you can do it. Yep, it's saying press the tally button 1 million times. Or actually, let me go 10,000 just to make it shorter. 1, 2, 3, 4. Yeah, let me make it 10,000. Okay, so check it out. if I go ahead and run it, we can see that, yeah, the first tally is 10,000. But if we wanted to represent this perfectly, 10,000 should be impossible. What should happen if we press this button again? All right, like you see how 9999. What do you think should happen if we press plus again? Well, honestly, it's up to you. It's whatever device you're trying to implement. For some people, they might want to do nothing, right? Like pressing plus does nothing. Or maybe for some folks, maybe you want to have the plus go back to 0. I'm not sure what you want to do, but let's say you want it to reset to 0, right? Like it overflows to 0. You could do some protection in the increment, right? Like you could go into this increment method and put in some protection, but basically you could do a something like if the value exceeds a certain number, then put it back to 0. All right, so you could do it over here. You could do it before or after. I'm gonna do it after. It actually doesn't matter too much, just however you think. But after we increment the value, we could do some protection. Maybe you could say, actually, I would probably do it before. It's more proper to protect before it happens. So you could do something like, if the value is at the last number, so if this value is at the last number, right, then we can just reset it. Right, so you could reset it by saying this dot value is equal to 0. This is fine. We actually wrote a method that does this for us already. So you can actually say this dot reset. It's the same thing. It's just going to grab this over here. Right, and let me put this in an else statement. So this is saying if we reach the last number, then reset it. All right, else increment it by 1. Okay, so let's see what happens now. So this is a protection. Let me protecting from out of bounds. All right, because we shouldn't be able to go past here. So yeah, for us, we're gonna reset it. And let me go ahead and run it now. So Java main, and yeah, so we get 0 and 0 now. People see why. It's because if we press it 10,000 times, we made it loop back to 0. We made it, yeah, by protecting the bounds. Okay, so here, let me do another question, another possible question. What if I were to increment it 10,005 times? Right, if I pressed the plus button 10,005 times, what's the number gonna be? What's the first tally gonna be? Let's see. It's 5. All right, people cool with that? It's kind of, it does go to there, but then it resets over here. All right, any questions about this, folks? All good. Okay, cool. It might be useful to do the same with the decrement as well. Like here, it's impossible to get negative numbers. Well, I think it's impossible to get negative numbers, but with our representation, it's possible, right? Like if I were to do something like, hey, let me remove this over here. Let me say like, let me just remove this over here, make it easier to read. What if I did something like tally.decrement right away? People see what I'm trying to do. So I'm saying declare tally. This does get initialized to 0, but then we decrement from it, and now we get -1. Right, that's kind of weird. It shouldn't really happen. So if you wanted to protect against that, it's well, first of all, it's up to you. Right? You can protect that however you want. In my opinion, pressing the minus button on a 0 should do nothing. So you could protect it by saying, if it's 0, do nothing. Right, so one way you could say is you could say if tally this dot value is equal to 0, or actually you can reverse it. You can say if it's greater than 0. Yeah, you can say if it's greater than 0, then subtract it. So this is protecting from negative numbers. So now we decrement. Let's see what happens. All right, now we get 0, and no matter how much we decrement. All right, see, no matter how much this gives me a 0 still, because this never happens. This never happens because 0 is not greater than 0. All right, people cool with this so far? Okay, let me save both files. Okay, hopefully people are okay. Let me think about this for a second. Oh, we should do one more thing. I forgot to talk about the very first part over here. There's something called a constructor. I forgot to talk about that. So, oh yeah, and then here's the anatomy of a class definition. You'll see this in the readings. Okay. Let's see. We should talk about the constructor real quick. So this is a method that initializes member values. Member values describe what the object is. Currently, we only have one member value. This is, let me comment it, member value. Currently, we only have one, but sometimes it might be necessary to create a constructor, like so here I'm using a default constructor, meaning I didn't create one, so the Java made one for me. So what's actually happening is there is an invisible method here. You don't really see it, but Java, when you compile it, it's putting in an invisible method here called a constructor. So the constructor is a method, right? It's a method. It's here. It has the same name as a class. So if you were to define your own constructor, let me define own constructor. So I'm gonna define an own constructor. One way you could do that is saying public, right? So we need it to be public because it's a method. We also need it to be public so the main can have access to it. All right, this is what we're trying to call this. The name of the constructor is counter, and that's it. Right? A constructor doesn't need any return types. It's a special method, meaning you don't need like a void here or anything. Right? It's just a special one. It's just the name of the class. So I was saying that the default constructor pretty much looks like this over here. It's invisible, but what's actually happening is it's using this method and setting the value equal to 0 here. So we're gonna get the same exact behavior. The only difference is this is using the custom constructor, right, which is really the same thing. But check it out now. Check it out. It's gonna get the same exact behavior. Right. So same exact behavior. If you want to kind of see what's happening, you could do some print statements over here. System.out.print. Let me do a print statement just so you can visualize. Creating counter. All right, there it is. So let me go ahead and run this now. And you see what's happening? There's two print statements, creating counter. So what happened here was we called the constructor 2 times. That's why it's creating counter, and it's initializing it to 0. This is kind of invisible if you didn't define it, but yeah, if you wanted to define your own constructor and like set it to something else, like let's say I made it 10 over here. All right, let me say I made it here. Wait, actually, let me remove these over here, make it easier to read. All right, so let's say I initialize the value to like 10 instead. Right, this is saying whenever we spawn a counter, start its value at 10. All right, so this is totally possible, and we create a counter and it initializes to 10. Meaning if we start incrementing it, like tally.increment, right now we're gonna get 11 and 0 because the first one starts at 10, goes to 11. So this is just an example. It's more appropriate to set it to 0. So yeah, that's what a constructor is. It's the goal of it is to really initialize its own member values. Right, it's yeah, initializing this over here. All right. Okay, so that's the constructor over here. Sometimes you might want to do something called an overloaded constructor. This is a more advanced topic, but it's kind of like here. I'm calling a constructor. Sometimes you might want to like spawn a tally that starts at a different number. like let's say I put a 10 in here. All right, so 10. You see what I'm trying to do here? I'm trying to construct a counter that starts at 10. This is very general, but unfortunately it's not gonna compile here. The compiler is telling me the constructor cannot be applied. Right, so the reason why it can't be applied is because our constructor is set up for no arguments. The no arguments means there's nothing in between these parentheses. So we tried passing a 10. We tried passing a 10 into here, but it doesn't take any parameters. All right. So one way you could kind of counteract this is by creating another constructor. So this is called an overloaded constructor. I'm attempting to call the overloaded constructor, which doesn't exist. All right, it doesn't exist. So let's make it exist. You can make it exist by saying by creating the same exact one. All right, you can say create a constructor, but overload its arguments. Overload means to have things inside of the parentheses, and here it looks like we're passing like an integer, and you can describe this integer as like a initial value. So you could say it's an integer and maybe call it like initial value. All right, so that means 10 is going to be sent into here, and then now we can go ahead and create it. So we can say when we create it, initialize a value to the initial value, whatever we pass into it. All right, and this is let me put a print statement in here so you see what's happening. So this is actually creating a counter. It's more like a custom counter though, and this is more of a default counter. All right, let me zoom out a tiny bit. Hopefully people can read this. Okay, cool. So we have two constructors. Let me comment this over here. So overloaded constructor, and then now we go ahead and test it. We see this first line creates a default counter. Second line creates a custom counter, and then yeah, we're just printing it out. All right, and yeah, you can increment in between if you wanted to. Like if you said like a tally.increment and then tally2.increment. All right, what do you think the output's gonna be? All right, reading this code, what's it gonna be? It's gonna be 111. Hope that makes sense, because 0 and then 10, and we add 1 to both of them. All right. Any questions, folks? Okay, sounds good. Let's move on then. So we just created our own counter class. I should probably upload this to Canvas. I'll do it at the end of this recording. But if you actually, I'll do it right now. If you're not able to keep up with like the typing, you can always download it from over here in the canvas files. Let me go ahead and upload it. I did create a new folder for this. Counter project. And let me sort it. Sort by date modified. Counter project. Okay, let me upload them. Upload. Okay, yeah, feel free to download these. There's like a download button over here. All right. Let's summarize what we did. We created a constructor which allows you to initialize member values. We also played around with methods like increment, decrement, reset. We did all of that. I wanted to summarize some terminology that we've been using. I've been throwing around a lot of words like private. Private is a keyword in Java. We typically use private to prevent misuse. You saw that in the beginning. It's preventing other people or other pieces of the code from misusing your code. If you get into software engineering, you'll probably find yourself creating libraries or creating classes for other people to use. I'll pull some examples up in just a bit. Actually, next week, I'll probably pull up some examples, like download other people's code and then use it. That's pretty much what I'm going to do. Download other people's classes so you see the bigger picture. All right, so private, we got public. This is useful for giving the user a safer access. All right, and we did that in the counter over here. These are public methods. They allow the user to interact with a counter safely. Right? Safely means that they're not really allowed to go past certain bounds. Right? They're not allowed to go negative. And these are public buttons. All right. Instance variable. This is another terminology I'm going to be using. You'll see this in the reading as well. What is an instance variable? Here, I'll pull up the reading over here. I copied it from here. I recommended the part 4, I believe. Part 4, number 1. And you'll see something over here. Oh yeah, they talk about the constructor. They call it the... Yeah, you'll see these words later. Instance variables right over here. All right, what are those? They specify the internal state of an object. So in our counter class, this is a instance variable, right? So you can say it's a member value or an instance variable. They're really synonyms of each other. All right. Let me see what else. Methods. Yeah, methods, object methods. These are methods that belong to the class and they specify what the object should do. They're typically public. They don't have to be public, but if you want users to use your class, they should be public. All right, and then encapsulation. This is a fancy word for saying hiding. Sometimes you want to hide code because some people really don't care about the code and they really just want to use your code. You know what I mean? Like over here in the main, in the main, you can imagine this left side as a person that wants to use your code. Right? Your code is right here. But maybe the user doesn't care about everything here. Like they don't care about these protection. They don't care about this protection. They don't care about how it works. So by making things encapsulated, this means to hide the implementation away. So I'm kind of hiding it in a different library and just letting the user use it. All right. Typically, you'll tell the user what methods are available. So we'll talk about that in just a second. Something called not the J shell, something called the Java doc. I'll probably talk about this next week. But a Java doc, this is a way of creating a manual for your class. So it's actually possible to use a tool that grabs your whole class and makes a manual from it. It makes a manual kind of like this over here, like you know how if you look at certain classes, like string class in Java. So if I look at the string class in Java, this is like a manual. More specifically down here, this table, it's generated. So it might look like someone is editing the website, like this right here, right? Who made this? Did someone modify this website and change this? Or over here, let's see the length method here. Right, you can click on this. Who's the author of this comment? Let's see. I mean, here I clicked on it, and you see how there's some detail. This is a manual. Right? It describes what the method does. So this is actually generated, by the way. This manual is generated from something called a Java doc. This is a tool that takes your code and makes websites from it. So it's pretty cool. Basically I'm saying when you publish code for other people to use, you'll want to use a Java doc, which will pretty much kind of summarize what these functions methods are, because some people don't care about what's inside of the methods. All right, so yeah, just some terminology. Okay, cool. Let's move on. Okay. We really just spent a lot of effort representing a fancy integer. We'll get a bigger picture next week. I'm gonna expose folks to some more objects. Probably let folks catch up with the reading a bit before we get into more advanced things. But yeah, here's some other things we'll see. There's some other classes we're gonna make here. Like some two-dimensional games are representing entities. Entities are things in that game. So like imagine you're playing like a two-dimensional game, like I'll just keep it super general. Imagine you're playing a 2D game. Entities are things on the grid. They have private attributes. These are like the XY coordinates. These are like variables that describe where a thing is. And we got a public interface too. A public interface, these are like buttons that allow the user to change these attributes safely. Like you might have like an up button, down, left, right. These are all methods that change these values here. It's just like the tally incrementer. It's just like the tally. These methods are kind of incrementing or decrementing these numbers safely. Right? But by safely, I'm meaning users won't be able to teleport. You know what I mean? If these attributes were public, it means that the user would be able to teleport. They'd be able to say X position is equal to 1,000,000 and Y position is equal to 1,000,000. That's probably impossible in some games, so you'll want to have a public interface that wraps these things. All right, so just like the counter, right? This is something we'll see later. I'm planning on deploying some sort of game that's like this right here. Let me see. I'm not sure what people are interested in this class, but maybe you've seen this game here. It's a very old game called a Galaga or Galaxian. I forget the actual word, but this is an old game on arcade. I think they still have this at the Santa Cruz Boardwalk. But yeah, you can think of this as a two-dimensional game with entities. Each entity can be represented as like an XY coordinate. Like this player is an entity, These enemies are entities. These bullets too. These bullets are also considered entities because they have an XY position. All right. So by representing entities as a class, you're going to be able to create multiple of them. Because remember earlier I was talking about like the cookie cutters, right? You could make an entity class and then create multiple entities from it, like an enemy, create a player, create some bullets, right? Those are all things on the grid. All right, so that's just an application. We'll do something similar to this later. Maybe Pong. I haven't thought about it yet. I'm trying to create like a really fun assignment for folks. Like, people heard of Pong before? Pong. Yeah, I'm thinking about creating something like this so people can understand things here. These are also like entities. You got these two paddles, and you also have a ball here, which is an entity. And by representing it as this class, you're able to kind of do some collision detection. Right? Collision detection is seeing if the positions are at the same spot. All right, so yeah, some pretty cool stuff. There's some other use cases too. Let me expose folks to some more classes. Right, the kind of the bigger picture. A car class. If you wanted to create like some sort of traffic simulator, you could represent a car as a class. Right? The car is a class, and then you can have multiple objects like Toyota. You can have Honda, Ford, whatever. But each car has different attributes. They have different horsepower, different remaining fuel, and there's also a public interface too. The public interface are buttons that the user is allowed to press. So all cars, I believe, allow you to accelerate. This is a button. This button relies on these private attributes, by the way. So your acceleration might depend on however these are defined. All right. The brake and the turn, these are all kind of like buttons, quote unquote. Right? If you were to design a car class, you would probably be able to make a traffic simulator, or you'd be able to simulate like autopilot or something. Let me pull up like an example here, like a traffic simulator. So you'll kind of see what's happening here. Traffic simulator. You could simulate traffic. You could practice making autopilot. Let's see. Let me pull this micro simulation. Let me see this one over here. So this is a website that simulates traffic. Let me choose a circle over here. There's a bunch of variables here. Like there's variables on politeness. There's variables on car's max acceleration. A bunch of other variables. But you can think of all of these cars as objects. These are all objects from the same exact class. But some objects are variable. Like the truck is probably slower. Cars are probably a little faster. And there's some variables. There's some randomness going on in here. You'll see. So if you kind of see right now, there's a traffic jam kind of about to happen. Let me see when it happens. Okay, so traffic is going. And then, yeah, it looks like there's a traffic jam now. Basically, the reason why is because there is some randomness going on here. Like probably politeness. I think politeness is like some sort of randomness. And yeah, you can kind of see that if you represent a car as a class, you could create a bunch of cars from it and kind of study behavior or simulate certain behaviors. Yeah, cool stuff. Now, next week, we're going to do like an example of like an RPG game. RPG, for folks who might have heard about it, it's like a role-playing game. You might be familiar with these bars here. This is like a stamina, mana, and health. These potions here. So you could represent an RPG game by creating a player class. There could be multiple players in a game, but those players will have similar attributes. Like maybe they have a string, a name. Maybe they have some numbers that represent their health, mana, stamina. And these are all private attributes, meaning they're not meant to be directly changed. So there should be some buttons attached to them. Imagine if we made a public interface, like a print stats. This is like displaying the bars. Right? It's like a print function, print method. Or you can imagine like a take damage method. That this is a method that changes their private attribute. Right? It kind of lowers their health here, and then a bunch of other things too. Just some more methods that interact with these. All right, so we'll do this next week. People will get a better picture on it, and I'm tempted to go into some more. Let's see. I'm tempted to download someone's interface right now. I'll probably save that for next week, though. So I'm just gonna let folks catch up with the reading just a tiny bit. Let's see. Yeah. Let's stop there, folks. Let me see where we're at. Yeah, we're now. Okay, perfect. Okay, yeah, let's stop right there. Next week we're gonna do a large example. We're gonna do like a player class to kind of simulate a small RPG game. And then we're probably gonna end up downloading someone else's code, something called APIs. So API stands for Application Programmable Interface. These are tools that people have made for you. So you can download other people's tools and use them, as long as you're familiar with the style of object-oriented programming. You'll be able to use a lot of these APIs here, like Reddit. I think Reddit API costs money, but some of these are free too. So some of these are free, meaning you can use objects to look at other people's data, kind of. For example, here, let me just pull up Twitter API. Twitter API. I think they call this X now. Yeah, they call them X. Let's see. So Twitter API. I'm trying to pull up some code that you might be able to use to look at Twitter data. Let me see. I think I gotta look up X API. Or is it here? I think it's over here. Okay, cool. So there's an X API. This is a social media platform. It looks like it costs money, but there should be like a free tier somewhere. Let me look for the. Oh, okay. Tools and libraries. Browse all libraries. I'm trying to find a nice one. Oh, okay, cool. So there's a Java library that allows a user to interact with Twitter. It's called a Twitter D right here. There's a bunch of other ones too. It looks like these are written in Java. Let me check out this first one over here. So this one led me to a GitHub. A GitHub is where some people store their source code. So here's some Java source code and a documentation here that describes how to use it. So kind of skipping through this, you'll kind of see the object-oriented style right here. Basically, if you were to download this person's code, right, there's like a download button somewhere around here. Yeah, so somewhere around here. But if you were to download the code, you'd be able to do some object-oriented programming, like here. Right, what is this doing? Well, you saw earlier that this is like a constructor. Right? We're saying declare a Twitter client. This is a class right here. So this is a class, this is an object, and I'm setting it equal to a constructor method. Right? That's like right over here. We did this before. Over here, constructor. So that's what we're trying to do here. And then you can use this object to grab some stuff. Like you could say grab some data here. Let me look at some more data. Go down over here, scroll down, and yeah, you can do some more object-oriented stuff here. Like you could say tweet. This is a class, and then call it tweet. There's an undercase, it's an object, and then say do some object-oriented stuff here. So this is using a method, right? It's a method that belongs to this Twitter client, which was declared up here. So you could get some random person's tweet, or not random. I think this is a unique identifier. But if you were to have that, then you could access the tweet's information. Like you could say, hey, where was the tweet created at? There's a lot of information you can get by just by using developer mode, like using other people's API tools. You can look at tweets language. You could look at how many people retweeted it. Yeah, some pretty cool stuff. Oh, you can also look at other users' information too. So if you were to download their code, it looks like it provides folks with like a user class, which is a class that represents a person. And you can use that object to get all of their data. Well, not all of it, but like their name, their display name, whenever they created their account. Looks like you can get the location too. That's kind of interesting. I did not know you can get a location. I don't use Twitter, so I didn't know this was possible. Okay, cool. Good to know. So yeah, that's just kind of a high level overview on what we'll do next week. We're gonna download other people's code and use it. I'm thinking about downloading some game thing though, just so people have a little more fun. All right, that's about it for today, folks. Yeah, we covered intro to object-oriented programming. This is going to be a pretty dense topic. It's going to take us another week to finish. So yeah, I'll see you all next week, folks. Have a good day.